So the final type of factoring is factoring a kind of trinomial when something's missing. And it looks like this. X squared plus 0x's minus, say, 49. Of course, they never write the 0x, because why would you write 0x? If there's 0x's, you would just write this as x squared minus 49, right? Now, when I write it just as x squared minus 49, and I say, can you factor that? You'd say, I've never factored something like that before, so no. But when I write it as x squared plus 0x minus 49, then it looks like a trinomial. And if we think of FOIL, how could I get an x squared? What would have to be first? X and x. Now, how could you get 49 so that the outside and the inside makes 0? 7 and 7. One would have to be negative and one would have to be positive. So what you're going to start to do, because it's never going to be written with the 0 in between, even though it's exactly the same technique that we've done before, you're going to go straight from here to here. And the reason it's called a difference of squares is because difference means subtraction. There's always a subtraction sign in between. And the last term and the first term are both perfect squares, because x squared is x times x. That makes it a perfect square. And 49 is 7 times 7. That makes it a perfect square. And so recognizing these make these some of the easiest ones to factor, because it's the only ones where you're factoring with two things where there's no common factor. So there's 3 for you to try, or maybe 4, let's see. No, just 3. And again, after you factor each one, do a quick check by multiplying it out to see if you're right. Okay, how did you do? Both sets of brackets, x and x make x squared. And we have to draw a little tiny O and I, because it's not really there, right? You'd have to have 2 and 2 to get 4, and one of them will have to be positive and one of them will have to be negative, so that your outside and inside disappear. Is 121 a perfect square? Yes, it is. X plus 11 minus 11. And it doesn't matter which one you make your positive and which one you make your negative. Is 36 a perfect square? Yes, x plus 6 minus 6. Three more. We still have two terms. It's still a difference. 144 is a perfect square. Is 9x squared a perfect square? Yes, because you can get 9x squared by doing 3x and 3x. 12 and 12. And one will be plus and one will be minus. Now, we're not done here yet, because if I look at each of those things inside of my brackets, you may notice that there's a common factor. Can you see in 3x plus 12 there's a common factor? What could you pull out? A 3. So That's 3 times x plus 4. The other one I can pull a 3 out as well, leaving me with x minus 4. And if I put those two 3's together, that's the same as 9 times x plus 4, x minus 4. So one of the things that we're doing is when we factor, we're always checking after we factor to see if it equals the thing that we had before. So after I did the 3x plus 12 and the 3x minus 12, then I looked back and FOILed it out, and sure enough, it was the same as 9x squared minus 144. But then once you're done factoring, you always look back within your factors and say to yourself, is there another common factor, or could I factor it even further? And in this case, there was. So you would have to write it like this for the final answer. Anytime that there's a common factor, it means that we could have done that first. And it's often the best idea to take a common factor out first. This one, because 9 is so obvious, blaringly, so I was trying to say, it's so obvious that it's a perfect square, and 144 is 12 times 12, that you would probably recognize the difference of squares first and go to this. But if you look at 144, can 144 be divided by 9? Does anyone know the trick for dividing by 9? If you add up all the numbers, 1 plus 4, you get 9. And if that number is divisible by 9, that means that whole number is divisible by 9. So you could have, I'll do it here in green as a different method, you could have taken the 9 out to start with. If I take a 9 out of 9x squared, I'd just be left with x squared. If I take a 9 out of 144, I'm left with 16. Then x squared minus 16 is a difference of squares. So then from here, could have gone x plus 4, x minus 4, and got the same thing. How many people had the 3x plus 12, 3x minus 12, and had stopped there? Should be the majority of people. Excellent. All right, we've got a difference. We've got a perfect square. We've got a perfect square. So it'll be 5x and 5x, 7y and 7y, one positive, one negative. No common factors. It's good. Can you see a common factor in the next one? 2, 4. So you could take a 2 out. If you took a 2 out, you'd be left with 50 and 32, right? And then you'd have to take out another 2 again. So I'm just going to take out a 4 to start with. And then that'll leave me with 25a squared minus 16, is it b squared. And then we're left with bracket, 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 5a, 5a, minus 4b plus 4b as a final answer. If you did it directly to start with, it's not wrong. You don't have to erase it. If you did this first, and my guess is almost all of you did this first, right? That's not wrong. But now you have to look and see if there's a common factor in my first set of brackets. I can pull out a 2. Leave me with 5a plus 4b. And in the second one, I can pull out a 2, leaving me with 5a minus 4b. And my 2 would go together to be a 4, and you'd get exactly the same answer as before. So it's not wrong if you do it the green way or if you did it the blue way. Generally speaking, life is easier if you can take greatest common factors out to begin with. Because if you do it right at the beginning, you just have 2 steps to solve this equation. If you don't do it right at the beginning, you got to factor out of both of them and then combine the 2's, so it's a little bit longer, but it's not that bad. 2 more. Is 500 a perfect square? No. Is 5 a perfect square? No. So right now, this isn't a difference of squares. What can you do with it, though? There is a greatest common factor. What can you take out of both terms? A 5. That would leave you with x squared minus 100. Now is it a difference of squares? Yes. Is x to the 4 a difference of squares? Yes. Because what times what is x to the 4? X squared times x squared is x to the 4. So we'd have x squared and x squared, 1 and 1. And this last question, if it was on a quiz, I would put it at a 2. And if we did this, you get 1 and a 2. Did I just make a mistake when I was marking? Should it be 2 out of 2? Or should it be 1 out of 2 and there's something missing or something wrong? Okay, how so? No? Wait. Okay. You're on the right track. First of all, but this first one, so with 4 binomials you're close, but this first one isn't a difference of squares. So the x squared plus 1, that's done. There's nothing more you can do with x squared plus 1. Because x plus 1 times x plus 1, if you FOIL it, you'll get x squared plus 2x plus 1. X squared plus 1 is already factored as much, but there's another difference of squares. Can you see the second one is another difference of squares? Plus 1, minus 1. And then you would get 2 out of 2. If I wanted to be really nasty on a test, I could go x to the 256 minus 1. Because then you'd have x to the 128 minus 1, x to the 128 plus 1. And then the x to the 128 plus 1 minus 1 could be done to x to the 64 minus 1 and x to the 64 plus 1. And then that one could be split in half to 32. And then the 32 could be split in half to 16. And then 16 could be split in half to 8. And the 8 could be split in half to 4. And the 4 could be split in half to 2. And then finally you would be done. would be nasty. That would be a long one. Oh, this is like a puzzle. There was a formatting box that came up. And when I took a picture of this slide, only the ARD showed from the formatting box. What might that have been? Probably not lard. So what's missing? The 2a plus 5. Excellent. And that's all there is for this unit. I've already given you the big factor worksheet. You'll notice as you get to the white one near the end, there's some difference of squares on there. I can go back.